Students of class 12, today we are going to discuss example 4.9. In this case it is given that a solenoid of length 0.5 meter has a radius of 1 centimeter. So 1 centimeter will be converted into meter and becomes 10 to the power minus 2 meter and is made up of 500 turns and it carries a current of 5 ampere. Then what is the magnitude of the magnetic field inside the solenoid? That is the problem we have to solve it. So we know that the number of turns per unit length will be, since there are 500 turns altogether and the length of the solenoid is 0.5 meter, so the 500 divided by 0.5 becomes 1000 turns per meter. Now it is also, as we have simply been given that length is 0.5 meter, radius is 0.01 meter, and thus L by R will be 50. Length is 0.5 and that divided by 0.01. So if you find this ratio, it becomes 50. That means the length is much greater than the radius of the solenoid. Here some confusion could be there because length is represented by A somewhere at by R. Radius is represented by R and somewhere by A. So now you take it as R, so it becomes L by R is 50. That means L is much greater than R, and therefore in this case we can use the formula for a solenoid in which length is much larger than the radius, and in that case the magnetic field is given by the relation B is equal to mu 0 Ni, and aid to memory is Billy Muni. And that means you have to put the value of mu 0, that is 4 pi into 10 to the power minus 7, and N is already we have calculated 10 to the power 3, that is 1000 turns per meter, and I is the current given, so that is 5 ampere, and that on calculation we find that it becomes 6.28 into 10 to the power minus 3 Tesla. So this is the field inside the solenoid produced due to 5 ampere carried by the solenoid having 500 turns and a length 0.5 meter and radius of 1 centimeter. Thank you and have a nice day.